Welcome back to our new Protocol Smart Contract series. Today we are diving into one of Rust's most important concepts, ownership and borrowing. We'll learn what they mean, see common mistakes developers make, and discover how to avoid them in your near smart contracts. What is ownership? Ownership in Rust's way of managing memory safely. Think of it like owning a car, only one person can own it at a time. In Rust, every piece of data has exactly one owner. When the owner goes away, the data gets cleaned up automatically. So let's write a function to show it. Let's create a message. It will be string. And let's write just hello near. And let new message equals message. When we assign message to new message, the ownership moves. The original message variable cannot be used anymore. Rust prevents this to avoid memory problems. So that means that we cannot use it anymore. So hello near, it's only new message. It's not for message. But here's something important things. Simple types like integers, u32, u64, u128, any integers, and bool are different. They get copied automatically. So integers are so small and simple that Rust just copies them instead of moving ownership. This makes working with number much easier. Let's look at mistakes new Rust developers often make. One of them is using moved values. Let's write a function to show it. Public function, let's be mistake 1. Dot clone. Let's be just random function, some function name. So here we need to clone it again for these functions. So here right now it will be an error because name was moved. So to solve it, we need to write one more time here clone. So don't move values when you still need them. Use borrowing or clone that we're using right now when necessary. Another mistake is multiple mutable borrows. Mute self, oops. Let counter equal mute self counter and just copy this and write counter 2. Right now you will have an error because here's the 2 mutable borrows. Don't create multiple mutable borrows. So here I need to write just one this. Last mistake is how to get the variable. Let's write another function. Let's get owner self. Oops. String self owner. Here it will be an error because you cannot return borrowed data from contract methods. Always return on with values using .clone. So here we need to write like this and without this symbol. Now it works correctly. So always when you need to return some value, use .clone. Okay, here are some tips for writing clean near smart contracts. Public function tip 1 self account string and just return the bool. Self dot owner equals account. This is forces caller to give up ownership. To avoid to give up ownership, we need to write ampersand and set true. Now it works better. So in functions, use ampersand and true instead of string. It will be much better. Another one, it's need to important when to clone and when to borrow necessary. So clone, it's better to return the data, as you can see here, and borrow is better for internal use inside of the contract. To avoid double mutable, use brackets and keep borrowing shorts. So here we can check our function mistake took. Let's return counter 2. So if we will write like this, it will be no mistake, no error. That's ownership and borrowing in near smart contracts. Remember, ownership moves data. Borrowing lets you use it temporarily, and following Rust rules prevents bugs and memory issues. Practice these patterns and your smart contracts will be safer and more efficient. Subscribe for more new tutorials and drop your questions in the comments. See you next time.